recording. We're recording. So, chapter 6 and onwards. As we were talking earlier, the chapter 6 content is mushed together with the chapter 7, and that's basically it. So, it's all kind of just one big chunk there. I feel that it kind of bleeds on from one to the next. You don't really see a line of differentiation. So, let's go. Normal probability distributions. Let me just tell you very quickly what this means. It means bell curves. Yep, we're doing bell curves. And we've been doing bell curves for a little bit, but now we're going to do them a lot more. If you remember, the basic understanding for the bell curve, wow, that's worst ever, was the empirical rule. Let me write that up again. Empirical rule, where we had 34%, and then right here we had 13.5%, and then like this was 68% within one standard deviation. This was 95% within two standard deviations. Remember that kind of stuff? Okay, so we're doing it again, but now 100% with GeoGebra, okay? GeoGebra is going to do all this stuff for us instead. But this is the idea. We've seen it before. Now let's go and do it for real. So what I want to do before I even get started, I want to show you GeoGebra, where we're going to go, what we're going to do, and how that works, okay? So let's do GeoGebra / classic to make it easy. And we're going to go probability, and there it is. Here we are, we're done. Now, just take a look around for a second. There's actually a little bit more here than what you think. Notice that we got at the bottom corner here, -1 to +1, and notice the answer, the probability of the shaded region is 68%. Didn't we just say that? See? Look at that. What if I were to go from -2 to 2? So -2 to +2. Did I just get 95%? Yeah, pretty interesting, right? So it's basically the same thing. Now, the constraints are that I'm using 0 and 1 for my mean and my standard deviation. Okay, so again, that's my mean, and this is my standard deviation. And so that way you make the empirical curve thingy stuff just by clicking on it. What we're going to do is change these numbers and change these numbers and get one here, copy, paste it in, and we're done. That's the entire class. Awesome, right? You're not excited? Very excited. Okay, so now you know where we're going. Okay, here we go. Hey, look at that! We just talked about this. Whoop, whoop. All right, blah, 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 blah. Do you all read this kind of thing? Me neither. And so you can see that we're changing the mean and standard deviation values, and you can see that we can basically do that right here, okay? And so they're saying, oh, well, what if I have a mean of 1 and I have a standard deviation of 2? And then you're going from -3 to +1, or let's go 5. There we go. Pretty interesting. So you can change all the different numbers to get different things. Okay. Oh, wrong one. All right. So here's an actual question from Newton. It says, given the plots, this and that, which of the following are true? So the mean is where the middle is. The mean is basically where your hump is. And so here the mean is going to be right there. This mean is right here, and this mean is right here. The mean is the middle, in a way. Sounds good so far? So let's look at the mean stuff it has here, okay? Standard deviation, we'll talk about that later. Standard deviation, right here. These are the mean. Oh, there's the means. Hold up. You see the two things here that are talking about means? Mean and a mean and standard deviation. We'll get to that in a minute. Okay, so A has a larger mean. Oh, has the largest mean. Is this mean right here the furthest to the right? Is it the biggest number positive-wise? Yes. So I like that. That's a check mark. B has a larger mean than C. So is B further along the number line than C is? Yes. So I like that as well, okay? So it's not about how high, it's about where it is location-wise. Think of it like a number line. And so if I had a number line here, where this is, let's do right here, let's do 0, 1, 2, 3, and then like 4 is way over here. And so the mean is in the middle, right? So A's mean is at 3. Is that the largest out of all these different numbers? Yes. Make sense? Go ahead. Right, it's so big. It's so big, isn't it? I'm not really looking at that. I'm rather looking at where its location is. And so this right here lands at 1. So the mean, the middle is at 1. And so if I'm looking, B is technically more than C because it's 2 rather than 1. Make sense? You got to think number line wise for a little bit, okay? Like if you want to like just replace all these things and just literally have out like, hey, this is where C, this is where B, this is where A landed. So which one, and this is 0 down here, let's say. So 1, 2, 3, 4. Which one is the biggest, right? Which one is bigger, C or B? B is bigger. Does it make sense? Okay. The tallness is a whole different thing. See, so far the mean is just where the middle is, right? That's easy enough. But now these tallnesses are telling us more about standard deviation. It's not really about how tall it is, it's about how they group together. So for example, let's say that I have a nice tight grouping all together versus something that's kind of like really far and expanded. Yeah. See how these are like really tight together, yes? So this is a smaller standard deviation. Smaller standard deviation. But this one's wider. Exactly. Yep, exactly. So this has a larger standard deviation. The standard deviation is a way to say like spread. Okay, so whenever you see the word standard deviation, it basically means spread. Now, if you're taking like a sand pile and you're kind of mushing it all together so it's a really tall little sand pile, it's not really spread out, is it? And so that would be a small spread, right? It's like humped all together, small spread. But if you kind of flatten it out over time, larger spread. Cool? So replace the word standard deviation with spread, and it makes more sense. So mean with middle, so that's on the right. Mean is middle, standard deviation is spread. So let's go through all the questions about spread and standard deviation. So standard deviation, so again, that's the spread of A and B are equal. So are A and B spread out the same amounts? No. So that's a no. We don't like that. B has a larger spread than C. Is B more spread out than C? Yes. Yes. C has a smaller spread than A. C is smaller spread than A. I would say yes again because it's taller. When you hump all that together, the taller it is, the less spread. So yes, that's true. And then finally down here, C has a larger spread than B. No, B's the largest. That's false. See how we can like replace these words? So mean, middle, standard deviation, spread. Make sense? So why don't we just call it that, Chad? I don't know. Good to go? Okay, cool. I figure it's not that hard as long as we kind of see some of the points there. I've seen this before on exams. I know that it looks easy kind of here. Once you start doing it, you'll get it, but you have to remind yourself when it comes test time. Okay? Remind yourself about it when it comes test time. Okay, so they give us a formula for z-scores. We already seen this. It says, remember, from chapter 2. Same thing here. We've already seen all this. That's no problem. I think they're going to want to do 1 or 2 questions, and then we can move on to better things here. Hello. So, newly hatched. Oh, emperor penguins. I love penguins. Have an average of this many grams, standard deviation that. Weights of the baby penguins, normally distributed, da-da-da. What is it whenever we have a penguin that's 310 grams? So that's the value. Notice that we have this right here is the mean, and this right here is the standard deviation. I'm just going to put it all together if you don't mind. Value minus the mean all over the standard deviation. And now I need to go use a calculator, but I think we can probably get this. 310 minus 315, what do I get in the top? Yep, -5, very good. Over 5, -1, yep. So that's the answer for the z-score. And again, we've already done this. I'm just reminding you. This right here is 0, so -1 is right here. Cool. Do you remember where it was that it was unusual? What's the numbers for unusual? Yep, exactly. -2 to 2 are the usual zone. So outside of that would be unusual. So is this score here, is this unusual? No, not unusual. That's a normal penguin. Do penguins waddle? That's what they waddle. Okay, he just waddles. Do baby penguins waddle? They do? They don't fly? Okay. I don't think the adult ones do either. Find and interpret 300. Okay, so let's talk about 300. Help me out with this formula. What goes here up first? And then 315 divided by? Perfect, thank you. So if I look at it, that's a negative, oh yeah, negative 15 over 5. Uh-oh, negative 3. Let me try to graph that here. That was the worst bell curve ever. 0, negative 1, negative 2, negative 3. Is this unusual? Yeah, this is actually called very unusual. Unusual. The very is actually a key word because it's more than just 2. It's now 3. And it's very unusually small. It's a tiny penguin. Oh, I hope that he's going to survive, the little guy. It gets cold where he lives. But he's got his parents to help him. All right, 319. Help me with the same formula. What do I put here up top? Minus divided by? Perfect, perfect. I got, what is that? 4 over 5, which is what, about 0.8? 0.8. So again, where's that on the bell curve? There's a 0, there's a 1, so he's like somewhere right here. Unusual? No, not unusual. So he's a regular penguin. We've already done all this, but are you understanding the kind of flow of it now? Awesome. Cool. Okay. Why are they doing so much with the same question? I don't know, man. That's kind of odd to me. Any questions on this? Good. We're just going to repeat the same thing a lot. So here we go again. Yay! More math. A z-score of 1 tells us x equals 2 is 1 standard deviation to the right of the mean. If the standard deviation is half, what does the mean? What? What does that mean? Did you get the joke? What does that mean? So it says use the same formula, but I'm going to give you a new one, okay? I think it's x is equal to mu plus z times sigma, okay? Again, that's the value is equal to the mean plus the z-score times your standard deviation, okay? So it says z-score of 1, x equals 2, oh, that's the value. Is that right? Standard deviation of this, what's the mean? I guess that's the best thing we got. Okay, here we go. So x is 2. The mean, I don't know what the mean is. We're supposed to find out what the mean is. Z-score of 1, and then times standard deviation of a half. What's 1 times a half? Is a half, yeah. Plus 1/2. So how do I get the mean by itself? Yeah, exactly. You subtract it to the other side. I'm going to minus the minus the half on both sides, basically. And so then the mean is 2 minus a half, 3/2. But rather, it's just 1.5, isn't it? So the average would be 1.5. They're not telling us what this means. The joke is too old. Stop it, Chad. Yeah. I don't know. It's just numbers. Let's go through this whole thing again. So it says, and I mean, we can use the older formula. I just don't think we like fractions. Do y'all like fractions? I don't like fractions. So this one here is a no fraction formula. It kind of is a little easier. So I want to use the same formula, and you can see all the stuff written there. Didn't we used to have the? No, we didn't. Not in this class. In my other classes, I'm trying this I do, you do, we do kind of thing. I don't know if you've ever seen something like that. Do y'all want to do this problem on your own while I stand here and have the recording like not have any words? Is that a yes? Let's do it. Finally, I get y'all to do something now. Whew. You know how much I've been doing for these months? Spuddy's actually trying to grow. He's got his little spudlets. These little spudlets going on with him. Or coffee. Yeah, I think coffee has nutrients too, but maybe that's just me. Same with like motor oil. Same thing. You're like, not the same, Chad. Not the same. Okay. I want you to tell me how at least this formula is going to look. What do I put here for x? 21 equals, what do I put here for the mean? 24. My z-score is negative 1.5. And what do I put for sigma? Standard deviation? We don't know it exactly. So now I need to solve for this. What did you do? What's the first step? Did you not get that far? Did I not get that far? Is this algebra class all of a sudden? What do we do in your Chad? Subtract it, yeah. I think I'm going to subtract it first and then mush those together. So yes, very good. And so then when I divide by a negative 0.5, which is totally outside the realm of this class, honestly, 3 divided by 3/2, I think it ends up being a 2. I'm going to have to verify. Negative 2? But hold on, I got negative on both sides. Is it just plain 2? Confirmed? Were they both right or both wrong? I'll take it. Statistically, we can't both be right and wrong, right? Okay, that wasn't a joke. That was a real question. 2. There we go. I don't know. Do we have to do algebra in this class? I mean, no, if you had a formula for it. There's just like I made this formula up here. You can make up a formula for standard deviation. You can make up a formula for everything. I'm going to keep cruising though, okay? It's a good thing to have a little bit of algebra in your life, right? Wrong. That's why I took this class. Jennifer's chemistry test score was a 94. Good job! Test scores are normally distributed with this much standard deviation and that much z-score. What was the average test score in the class? I gotta say, a z-score of 5 is nuts. That just doesn't happen in the real world, okay, guys? But we're gonna see what it's like. This is awesome. So we got, actually, yeah, x is equal to the mu plus the z times the sigma. What do I put for x? What's my value? 94 is what I got. The mean, I don't know. What's my z-score? Standard deviation? Okay, so I got a 10 right here. So 94 is equal to mu plus 10. And now what do I do? Yep, move the 10 over, subtract the 10. Very good. And so the average is an 84. There you go. That's the average test score. You don't get a z-score of 5. That's just nuts. Like 3 is like, whew, that's pushing it. That's very unusual. So okay, would a 4 then be a very, very unusual, and a 5 would be a very, very, very unusual? Very, very, very unusual. Yeah. So yeah, Jennifer made a very, very, very unusually high score on her chemistry exam. Bam. Okay. Moving on. Okay. We just talked about this. We just talked about this. Star. That's all I can say about that. We've already talked about it. I want to show you GeoGebra here in just a second also, kind of compare and contrast between the two. So in an algebra class, most recent test scores, we got a mean of this much, standard deviation there. Use empirical rule to find out what are the other guys. So what would be usual, unusual, very unusual scores, right? Either way. So I'm going to use the same thing. I'm just going to draw on top of it if that's okay. So 78, right in the middle. Boom, there it is. And they say that we're jumping by 4. I'm going to add 4 on this side, minus 4 on the other side. What would I then have right here? Yep, 82. And then I'm going to do another 4 to get a 86. And then finally, okay, on the flip side, we're going to minus 4 each time. So I'm getting a that's tough, isn't it? 66, that's not good. And so the way this is given, it seems that it would be usual, unusual, very unusual. It'd be very unusual to fail the exam. That's not bad. Right? Okay. I don't know what else they're wanting from us here. Yay! Check mark. We did it. Okay. A data set has a mean of this, standard deviation that. What's the probability of this much here? Okay. This one's not too bad. I'm going to use a different color though. Let's do orange. So it says I have a mean of 24. I'm going to put a 24 right here. I know this is like kind of on top of the same problem. Sorry. Standard deviation of 3. And so I'm going to go minus 3, and I'm going to say plus 3. Right? But before we go do that, just for a second here, it says 18 compared to 24. We're going negative or positive here? Negative. We're going to go backwards, right? So if this is a 24 and I'm minusing 3, I get now 21, and then finally the 18 that I'm looking for. So this is where they're talking right here. Now it says, what's the probability of less than the 18? So they're saying all this stuff over here. They're like saying all this and it'll keep going forever. It's like really thin, but what's that probability there? And it's not just 2.35. It keeps going a little bit, right? So how are we can find that? If you remember, how we approached this problem is we said that we have on this side 50%, 34, 13.5, and I'm wanting all this stuff over here. So what do I do with these 3 different numbers? 50, 34, 13.5, what do I do with these? Yep, exactly. Subtract them from the 50, very good. Take the other 2 and subtract them from the 50. Like we already did this a while ago. Blah, 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 2.5%. There you go. And that kind of matches up with that 2.35 right there. It's not 2.35, it's a little bit more, right? There's a little bit more after that, but not much. You can see that it's adding just a tiny bit more to get to the proper value. I'm going to do one more here. I got one more. Yeah, and then I want to show you GeoGebra and how they approach this, okay? So we're almost there. I'm going to kind of show you around there. Newborn babies average this much. Let's use a different color. Average, standard deviation. What's the probability of more than 8.1? So I'm just going to set up a bell curve for this, just like we normally would. In the middle, I start at 7.4. Our interest is in 8.1. Am I going to go negative or positive here? Positive. So then I'm adding 0.7. How much would I get then? Say it again. 8.1, and then I'm going to do it again. Oh, wait, never mind. It's right there. We're already done. So they're saying more than the 8.1. They're saying all this chunk right here. Do you remember how we do this again? There it is. There it is. 50%. And then we got the 34. So the 50 minus the 34, 16%. 16% probability of more than 8.1. given these numbers. Cool? Okay, now I want to show you GeoGebra. Can I just use GeoGebra now that you showed me, right? Can't I just use GeoGebra to get the right answers? Kinda. So I'm going to go back to this one right here. No, we already did that. That was the blue stuff. I want to do these two. So I want to get 2.5 and I want to get 16. I want to see, can I do it? So let's do the mean was 24. Actually, let me just side by side it if that's okay. There we go. That's close enough. Okay, so the mean is 24. I think we can get better than that. Yay! Now I can see everything. And the standard deviation was a 3. See, I'm just changing my numbers there. And they say less than 18. You can change all of them right here. And so you're basically just saying less than 18 right there. Now, sure looks the same, doesn't it? So why is it that I got a 2.5 and they got a 2.28, right? A little bit different. It's because it's not perfect. Empirical rule is not perfect. GeoGebra is perfect. Empirical rule is not. It's just whole numbers, basically, right? They're just rounding it off. And it's close. So could you look at this and say 2.5? But watch the next one. The next one will tell more, okay? So let's do it all over again. I have a mean of 7.4, standard deviation 0.7, and then it says more than, so I'm going to click this button right here, more than 8.1. Now, when things are going like smoothly, and you kind of already know some of the answers, 15.87, round to the nearest whole percent, 16, right? So it's close. Can you use that? The only problem is that the reason why it's not matching up perfectly, which again, this is all one small thing. If we go back up here, it's because we're using empirical rule. We're using the imperfect. It's not perfect. It's close, but it's an easy way to do it. We won't stay there. It's just for a little bit. Is that okay? Okay. So real quick, because if you see what's next right here, it says, look, we're on the next section. Well, hold up. Do you remember our chapter 6 stuff over here? Did we just do this 6-1 homework right now? It's done? The end? I don't know. It seemed kind of easy, didn't it? And now we're just going off to the next thing. Do you mind if I like cruise around the homework for a bit? I feel like I might have forgotten something, or maybe they did or something. It just didn't seem like it was just too easy. I didn't even get to use GeoGebra properly. How could you call this a real stats class? I'm not really crying. I was just joking. I know. I'm trying, guys. I'm trying. Okay. We got an average this bowling game. Standard deviation of that much. Oh. I don't know what they're trying to say here. Let's get some paper up. Blank paper. Okay. Because I want to draw on it. Draw. No, not highlight, draw. Okay. Where's my homework? Here we go. So we got this much score. Z-score of, the Z-score is this much. The mean is that much. Before I keep going, what is the mean? What's the average? Didn't they say that somewhere? 149? Awesome. Okay, well, I don't know what's going on here, but we can find the Z-score. Z is equal to the value, the X, minus the mean, all over the standard deviation. What goes up top? What's my value? What's my X? 186. What's the mean? What's the average? Yep, 149 divided by standard deviation of 14. I need like a hand calculator for this because going here is just kind of disappointing. 186, 149, 186 minus 149 divided by 14. we go. 2.6 for 3 decimals, 3. It says the z-score tells you this is blank standard deviations away. Let me just try this guy here. I'm going to hit submit and see what happens. Sweet. So let's pause and talk about what's going on. Can I go and calculate what that z-score is? Easy enough, right? No problem there. The mean, didn't I just copy it down? But what's this guy? Well, obviously, it's the same as z-score, but what it's going to say is it's the absolute value of that. Have you heard of absolute value? Always positive. So they're going to have the same number. Like if I got a negative 2.6, we would still put a positive 2.6 here because they're going to say blah, 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 blah. And you can see right here to the right, they'll have also to the left sometimes. They're just wanting the positive value of it, okay? Blah, blah, blah. Let's do another one. Yep, perfect. Okay. I don't even have to write it down, I don't think. So this is a fraction. What's my x? Awesome. What's my average? 9, very good. You can see this little thing that we've been seeing once in a while. And then standard deviation? 1.5. Thank you. So 3. 3, the mean is 9. It's still a 3 because it says on the right side. I wish it would do the other way so I could show you, but that was it. That's it. That's all we're doing here. That's not too bad. I like this homework. I don't like this homework all of a sudden. What's going on? So scores an average of this much, and her points bowling game is this, scores this much, and those are really good scores. Z-score of -3. What's the standard deviation? We already had these kind of questions. Did we already do this earlier? Yes, Chad. What's my value? What was her score? 136. What's the average, apparently? 178, very good. The z-score, they say, is -3, so what's the standard deviation? And you don't have to have a plus sign here because that minus sign kind of takes care of that. So I want to solve this thing. Can you remind me how we do this in algebra land? What's the next step? Very good. Subtract the 178. Can I just get that number? 40, is it -42? It is? Can I do math? Can I do math? And it's going to be like, no, you can't do math. Okay, sweet. Okay, and now, how do I get rid of this -3? Yep, divide it over to the other side. So 2 negatives cancel, make a positive. 42 divided by 3, 14? Straight up. 14. Yay. See, they're doing the same thing that we're doing. Cool. You nailed it. Did I have a hammer? What's going on? Same thing here. We've already seen all this. Instructor cheat. Yeah, I just cheated on you. I'm sorry. Why can't you have that button? Look, it's one of these kind of questions, right? Yeah, we talked about this. So it says, we're just going to look at it. So A has a larger mean. Remember, middle. Does A have a larger middle? No. B have a larger middle? Nope. They're the same. And now standard deviation, again, spread. Who has more spread? A has more spread. A has a larger spread. There we go. Very, very straightforward. So I'm glad we saw that again. Oh, I love this. Okay, so the middle. Who has a larger middle? B, because it's further on the right side, number line-wise, right? So B has a larger middle. Who has more spread? A has more spread. There we go. Straightforward. Awesome. We already had one of these. Is this on the left finally? Oh, yes! Whew. Here we go. We can do this now. Oh yeah, you can refresh the page to reload it. Look at that. Oh, look how so nice. Okay, so z, we're drawing here. Z is equal to x minus mu over the sigma. What's my value? What's the value he had? How many points did he make on that one day? 7 points. Average of 22 divided by standard deviation. 4. Yep. Calculator. So here we go. 7 minus 22 all over 4. So what they're wanting is the negative right here. 22 mean. But then they want the positive right here. Always positive. I'm going to verify. Bye. So there we go. Notice again, negative, because that's what our answer was. Easy enough. But then they always want the positive value down here. So when you're doing the homeworks, now you know. It's not. Is this all the homework is? Yes. I'm going to keep cheating, okay? Sorry. Man, what a cheater. We already did this kind of stuff. But I like them. Determine which has the smallest mean. Which one's on the left side, all the way on the left? A. A is on the left side. Yeah, exactly. Cool. Okay. Oh, these guys. We already did this problem. It's literally the same problem we just did a second ago. I'm going to cheat on that one. Man, you're doing great. Way to go. Cheating. We already did this standard deviation stuff. That was the last thing we just did a second ago. I want to look to see if there's anything new. Give me something new. Cheating our way to confetti. Bum, bum, bum. I'm just making up a new song now. All right. So supposedly this is actually a new problem. After collecting data, blah, 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 use empirical rule. See that one? How we're having to draw it out and all this kind of stuff. I'm going to try to cheat because that's what I do, right? I'm Chad the Cheater. Ooh, I like that. That's a new name for me. So Chad the Cheater puts in 149. I'm going to put 16 minutes, and it says less than 165. So I want the bar to be on the other side there. And I'm going to keep clicking buttons and drawing numbers until I get it right. I want to know, does this make sense graphically without doing any math right quick? So less than 165, all the stuff over here, graphically that makes sense. Look at that, that's 165 right about right there. What do they have for the answer? Round to 2 decimals, what do you think? 84% sounds pretty good. If as long as it's kind of in the whole number zone, I'm thinking that it's going to be no big deal. So can I cheat? Yes. Yes. And that's just because I'm literally just cheating, okay? I'm literally just cheating. It's not going to happen every single time. Don't get nervous. Okay, let's do it again. I have an average, 248. At minimum, you can use this. It says less than. At minimum, you can use this tool just to graphically see what's going on, right? Less than 206. Does that look like it's less than 206? So we're going to get a small number. If I were to graph this on empirical rule, I could probably say what? It's like unusual now. It's in the unusual zone. 50 minus 34 minus 13.5 is 2.5. It's not exactly the same. We did this problem before. See? So what I want to do instead is I want to show you doing it by hand because I have to be a good teacher once in a while, right? No, I don't? Okay, good, thanks. Huh? No, I'm using Edge, and it just draws really well. Yeah, I am pretty weird. Not a fan of Microsoft, but oh well. I just got recorded saying that. They're going to shut my account down. Yeah, I know. It's totally over, man. I'm going to be banished. So there's my mean. And the standard deviation is 21. That means that I'm going to subtract 21 or add 21 like this. But let's focus on the less than side, right? Because that's smaller. So let's do this properly. 248 minus 21 is 227. I'm going to do it again. And so what do I get here? 206. There we go. So this is the point where I was wanting, and it says less than. So all this stuff right there. That's just like the picture we had a second ago. If you remember, this is 50% right here. This is 34. This is 13.5. 50 minus 34 minus 13.5 is the 2.5 that I just put in. We've done this before. We've done this. And so if you go through enough of these problems, you'll just remember some of these numbers. It's always the same. Cool? Awesome. But now we can also cheat. Yay. Yeah, I'm just going to go back to this stuff here. I'm a big cheater. And I'm being recorded saying that. It says less than the 26. You see, look around. Does that look okay? Something looks weird. It's not shading it correctly. What if I like scroll a little bit? It's not doing anything. It's kind of weird. What if I put like 27 in? 25? 24? Why is it not shading anymore? I broke it. Yes, reload. Oh, okay, we're back to normal. Oh, man, it knew I was cheating. And then Microsoft tried to shut me down. You talked bad about Microsoft Edge? It's over, bro. Look, see, now it works. Can't catch me. Cool. What number are they? Take a guess what this will be. Yeah, it is. Oh, I was doing the European dot. There we go. Once you know these couple, like literally a handful of numbers, you can just look at it and say, I've seen that before. Because we've done this before. There's nothing new here. We've done this. Oh. Should I actually do this problem? You're like, no, and you're like, eh. Yes, let's do it. That way I feel accomplished, because this is like the last question, right? Look, we're already there. Now I'm going to feel good about my day. I'm going to go home and say, you know what I did today? I did math even when I didn't want to. And I get all the congratulations and the pats on the back. I know, right? It's like, wow, you actually did your job? Great job. Average of 73, standard deviation of 9. So then I'm going to have, when I add 9, what am I going to have now? 82, and then 91, and then 100. So it's right here. Very unusual. So, and it says less than. So it's like all of this stuff right here. All this stuff. So what we have right now is 50% plus the 34 plus the 13.5. And if you remember this one, it's 2.35%. So 50 plus 34 plus 13.5 plus 2.35 is, I hope, 99.85. Cool. I don't know what they're doing. I'm just doing my thing. Good? Feels good, right? And you're thinking, Chad, we got to go. And I'm like, no. Hey, we got time. You promised. You guys promised. You're like, I don't remember promising nothing to you, dude. You're thinking that. So let's keep cruising. If it's just that easy, let's keep going while it is easy. And it is. This next one here is a little different. They're wanting to use tables, which suck. Tables suck. And so I'm going to use GeoGebra basically all of the time right now going forward. So they're wanting to use tables. I'll show you how to use tables. It's not hard. Notice that right here they're saying 1.1, and then you have this. So that's like the first chunk, and then you have a 1 right there. Like I'm saying, I'm splitting it up. 1.1, and then I have a 1 on the outside. So 1.1, and then I have a 1 on the outside. That's how they're matching that stuff up. Okay. Will we have to do this ever? No. But can I try to do it just once or twice maybe so I can say that I did it for my job? Thanks. So 1.3, 8. Match it up. There's my answer. Doo-doo-doo-doo. What? Subtle difference. Very subtle. What's the difference between what they have and what we have? Yeah, greater than, less than. The alligator's turned, right? What they're saying is greater than this amount. Real quick, graph it on this empirical rule, right? 0, 1, 2. We got 1.3 is like right here. So far, so good, right? Well, let me shade in what we just got. So I'm gonna use a green. So I shaded in the less than side. Look at my bell curve for a second, right here. All this. Do you think that that's about, I don't know, 91% or so? What do you think? Looks about right. And that's why we got the 91 right here. But they're wanting this side of things. So how would I actually get this amount over here? Yeah, say it. 1 minus. 1 minus. Very good. So 0.838. And yes, I've become a professional at 1 minus over the past 17 years. So do you want to know the trick? Y'all don't want to know the trick. You're like, just use a calculator. But yeah, just use a calculator. But each one of these columns needs to add up to a 9, except for the last one adds up to a 10. There's the trick. Could I do that in GeoGebra and save all the time in the world? The answer is yes. You start with the 0, 1 default. And in fact, if you don't know anything else, you just reset. Just refresh the page. And now it says you want more than the 1.38. So I'm going to click the more than button. 1.38. Did I get the 0.0838? Like literally on the dot. So, hey, Chad, why didn't I just do that? Exactly. That's what we're going to do. When they're asking about tables, we ignore the tables and we move on. So, I still will use them just because, just in case, but it's right there. Hey, let's not use tables. Let's just do this right here. It says between. I'm going to click that button. I don't know, one of these buttons. The main purpose of me clicking this button versus that button, I just want to make sure that it looks right. Like, does that look right to you? There it is, see? Does that look right to you? And it looks silly, but if you look closely, did I go from 1.2 to 1.3? Basically. The answer is 0.180, yeah. And they pretty much want 4 decimal places every time. Look how easy. It is easy. It should be easy. Good? Good. Look at this wonderfully huge table that you'll never need ever again. It says, what's the area on the left side of 1.23? 1.23. I'm going to leave this up for you for a second using the table. Whoa! Okay, there we go. That's totally within. We're looking again for z equals 1.23. I'll wait. Huh? 8907? Oh, you already got the answer? Oh, wow. And this is why in this class we just I don't know. It's just a lot of blah blah. In algebra, I can have y'all do it for a few minutes. Like solve for x. Super easy. Here's another one. Let's do it again. So notice the picture. Notice the picture's on the opposite side of what they have here. So they're still talking about negative 1.39. Negative 1.39. 8%. But does this picture look like that's going to be only 8% of the whole curve? No. So what am I supposed to do with this 8%? 1 minus the 8%. Exactly. 9177. Let's test it. So I'm going to do this. 1.39. Look at that, I got it. Every time. Ugh! Chad math. We got this, guys. I know, right? This is exciting all of a sudden. Man, I'm getting so excited. No, just calm down. Just calm down, okay? I know they're getting so excited. Okay, what's the area that's on the right side of this but on the left side of that? Pause. What are they even talking about? Sup, bro? You got something for me? Oh, have fun. It's okay. We're just being recorded. So I got a negative 1.36, and then I got the positive 1.21. Something went wrong. I did not put in infinity. I didn't put in infinity. No, I didn't. There we go. Oh, I'm putting in the wrong numbers. Okay, sorry. Let me start over. I've got two numbers I was putting in the wrong thing. There we go. Does that look right? It says right side of this and left side of that. It's almost like it's flipped, isn't it? That's a huge walkthrough. Oh my gosh. They're all walking through. Should I close the door on them and say you're loud? Or should I try to just let it go? Like, no, you're not really bothering me. Notice, so this picture doesn't look right. So what if I click this one here? You see the difference? I have the two numbers still, but now it's saying the wait, that lies on the right side of this and the left side. Oh, actually, I think it is the other way. Yeah, it was this. It was on the right side of this and the left side of it. Bigger point, though, is that you can do this and you can see the two different answers. Is that cool? So make sure it makes sense. And so, yeah, let me just verify the right side of this. I can't draw on this. Okay. Okay, there we go. The right side of this one, the left side of that, yes, it's in between. There's my answer, 7999. Awesome. Do you think they'll accept 0.8 for this one? No. Definitely not. They are very, very picky about this stuff. They're walking, we're talking. Let's keep cruising. The mean incubation time is for a fertilized egg is to be kept at this much for 20 days. Are they talking about a chicken egg? Do y'all know anything about doing eggs? I'd put eggs once in the incubator, actually 3 times. It worked out. They actually made little chickies. Hi. Should I stop recording and we can also hang out? Oh, do you want to be on my recording? Okay, I'll ignore them. They're walking through my room. It's okay. Y'all just be famous on YouTube, right? That's what it is. I'm just playing with you guys. It's funny. Don't look at them. Just look at the math. So notice that it says the mean is 20 days. This temperature thing has nothing to do with anything else. Standard deviation of 1.5 days. So hatches in less than 18, blah, 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 blah. I'm just going to put it in here. Put it into GeoGebra. And that's where we get the answers. 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 I'm just singing. It'll be for the folks at home. Do you think we can make a catchy new tune? Then we get like 1 million subs, right? in like no time at all. It's like, man, that was just the catchiest little tune ever. Ha ha ha. I'll give y'all some credit, you know, but none of the money. So I'm putting in the numbers here. Do y'all have any kind of questions, I guess? Any questions about what I'm doing here? I'm just like typing in some stuff. It says more than 22, 22, 23, 24, 25, 26. Does that make sense? Yeah? Are you Oh, it does make sense. You took stats. You know what's going on here? Okay. They don't want to come in. It's fine. 0.0912. Anyways, back to chicken eggs. Chicken eggs are pretty cool. You hatch them, get little chirp chirps. See ya. Fish lengths. How much more do we have? I think we should probably stop right here, right? What do you think? I came to class late. Y'all want to go? You're done, bro. You are going nuts over there. You're like, I'm so done with this class. Okay, so real quick, we got fish lengths. Mean of 11, standard deviation 4. So it says, what's the percentage that are longer than 13? So let's go and do that. Look, all this is 11, 4, longer than 13. Does that look like longer than 13 to you? Right? 13, 14, 15, 16, 17, 18, all those numbers are included. So we're cool there. That's what I wanted. And so then we got, for part A, 0.3085. Sweet. Now, this is where things get a little fishy. I'm very serious. This is actually one of the moments you got to pay attention. Notice that we have 300 fish. So how many fish would be shorter than 10? This is the problem, is that I'm so used to saying 300 of 30% is like about 100 fish. We're done. But no. They're saying a new number shorter than 10. It's a brand new problem, okay? So what I need to do is say shorter than 10. Let's do shorter than 10, and then we come back and talk about the 300 again. So that's 40%. Cool. Now, of this 300, how would I interface with the 300? What do I do with them? I have to have a 300 here somehow, right? What do I do between these guys? Subtract? Multiply. You're saying 40% of the 300. That's a calculator thing. I got Desmos up somewhere. Say it again. Oh, you're doing something else. Okay, that's cool. Where's my Desmos, bro? Like, literally, it's the last problem of the day. Can we just go home? There it is. Okay, we got it. Okay. 300 times the 40%. So, yeah. Does that make sense? About 40% is about 120 fish. Good? Great. Any questions, guys? We did a whole bunch today. Look, we're like getting there. Thank you for hanging out today. Yay!